this section I'd like to talk through doing a top cylinder overhaul. There are a couple of special tools that we'll need to do this, one being a cylinder base nut wrench and the other being an intake gland nut wrench. Again, like the manuals, we have these available if you don't have them. To begin our process, we want to make sure that the cylinder that we're going to remove is at top dead center on the compression stroke. Now, it's not important that it be on top dead center on the compression stroke for us to remove the cylinder. It could be at top dead center either stroke, but for the sake of replacing it and adjusting the valves afterwards, we want it on the compression stroke, so we may as well start off with it being on the compression stroke. Now, on any cylinder that we remove, except number 7, it's important that it be on the compression stroke, but it's not important once the cylinder is removed whether we move the link rod or not. The link rod can move side to side. We don't want it to hit the case, but nothing disastrous happens if the rod moves around. Number 7, which is the master rod on the Lycoming engine, it's very important that once that cylinder comes off, that rod is not disturbed, that it's left in the center of its travel, and it doesn't move side to side. The reason for that is if number 7, the master rod, moves side to side and all the other cylinders are still in place, what will happen is it will allow the other rods to move beyond their normal travel, so that a couple of the other rods, if you move the master rod side to side while number 7 is off, a couple of the other rods will travel beyond where they normally travel. The pistons will actually come out of the cylinder inside the case and the rings will spring out. Then if you try to turn the engine over, that will push that piston back up in there. It will break the rings and sometimes even breaks the bottom of the piston off. So it's very important on number 7, if you remove number 7, that it be left alone and left right in the center of the travel and not moved side to side. If you're doing a complete top overhaul where all the cylinders are coming off, number 7 should be the last one to come off and the first one to go back on again. That way it's not, nothing is disturbed in the other pistons and the other cylinders. They've all been taken off first and they all go on after number 7. So that's a really important thing with that with the master rod. We'll take a crankshaft turning bar that I happen to have here. We'll put it on the crankshaft. The crankshaft has a blind spline. It's made blind by a pin that is placed in there. If you look at the close-up of this, you'll see a pin that requires that the prop only go on one way. And so our turning bar also has a blind spline, and we'll align the blind spline on the turning bar with the blind spline on the crankshaft. And so there's our blind spline on the crankshaft. This is the top of this. The blind spline always points towards the piston that is at top dead center at any given time. So right now, with that blind spline in the location it's in, I know that number 1 piston is at top dead center. Now I don't know whether it's on the compression stroke or not, so we'll have to turn it through a little bit to find out. But as we turn the engine through, we can be assured that it's at top dead center number 1 right now. Now we're at top dead center number 2, number 3, number 4, number 5, and so on. So we'll turn this through, and I've got the spark plugs taken out because if we're going to pull a cylinder, we would want to start off pulling the spark plugs. And so I'm going to turn this through, and I'm going to feel for compression as I come around and see. Okay, it should be coming around top dead center. That's not the compression stroke. So we'll try this one more time. We'll come around. Yeah, that was it. So now we know that that the number 1 piston is at top dead center, and we're on the compression stroke, so that if we're going to pull the number 1 cylinder, this would be the place where we would want it. If we want to pull number 2, we would turn it around and make sure that we were at top dead center compression stroke on number 2. So we're setting it up for number 1 right now. What I'll do is I'll talk through the things that we'll do first on the front side of the engine, then we'll go around to the back side and take a look at that. We've already removed the spark plugs. We're already on top dead center. The next thing to do would be to remove the rocker covers. Once you've removed the rocker covers, the rocker adjuster screw will be exposed on both of these push rods. It's not necessary, in order to get the push rods out, it's not necessary to take the rocker arm. The rocker arm bolt goes through here, and if you wanted to take the rocker arm out, you'd have to take this bolt out. There's really no reason to do that if what we're doing is just pulling the cylinder. Just taking the adjuster screw out, you have to unlock it first, take the adjuster screw out, then you can use a magnet to reach in there and get a hold of the steel push rod, and it will pull the push rod out of there. So you can remove those without removing the rocker arms. Once you've got those out, then you can take the push rod tubes off the front. The push rod tube has a packing here in those locations, and then it has a hose in these locations. After any real amount of time on the engine, these hoses will have taken a set, and they're very, very difficult to get off. You'll probably have to cut them off. So if you take the clamps loose, move the clamps out of the way, and then very, very carefully use a utility knife. Be careful not to scratch the tube, because then you can allow a leak to begin at that point. But very carefully cut through and then unwrap this hose, because it's unlikely that you'll be able to move it. It's taken a set in its location. Once you've got the hose off, then these tubes will swing out. You can pull the packings out, and that's about all that you can do on the front side of the engine. Now we'll move around to the back side, and I'll show you the things that have to be done there. Okay, back here, the first thing that you'll have to do is remove the exhaust system. On ours, we have the short stacks on here, so it's not a really big deal. But with a full collector, you'll need to remove the exhaust segment that is on the cylinder that you're working on, plus probably the 2 cylinders that are next to it, and you may need to loosen the entire exhaust system and move things back a little bit so that you can get that one segment out of the way. Then you can go after the intake pipe. You have 3 nuts here at the intake pipe flange, and then this is where you'll need that intake pipe gland nut. Wrench is to take this gland nut off down here. After that, the intake pipe will come out, and that will be free. Now, if your engine is baffled, you'll need to remove the baffles at this point. And the baffles come out fairly simply. There are 2 screws on the front side of the baffle, and then there's 1 on the rear side. So this one down in here will need to come out, and then you can take the inner cylinder baffle out. There's no real reason to take the head baffles off. If you're going to reuse the same cylinder, then you can just leave the head baffle on. But the baffles on either side of the cylinder that you're working on will need to come off. Once the baffles are out of the way, then you can get down to the cylinder base nuts. There are 4 cylinder base nuts on the rear and 4 cylinder base nuts on the front. So you can take the PAL nuts off, then using that cylinder base nut wrench that we looked at a little bit ago, take the rear cylinder base nuts off, and then we can move around front to do the front side. Okay, now we're around in the front, ready to take the front 4 cylinder base nuts off. If you have this style shielded ignition harness on your Lycoming engine, this is where things get interesting, because this ignition loom, while it looks really pretty here behind the pushrod tubes, is blocking the front 4 cylinder base studs. So it's very, very difficult to get a cylinder off with this harness on there. What you'll have to do is loosen this harness. There are 4 nuts that hold this harness to the nose case. You can remove those and then pull this entire harness forward, and you can pull it. Oh, and it doesn't move much at all, but you're right up against the cylinder the way it is bolted in there now. So you can pull it forward and wire it forward so that it's out of your way, and then you can get to those last 4 front cylinder base nuts. Okay, at this stage, the cylinder is completely free and completely unbolted from the rest of the engine, and so it's ready to remove. Since we're talking about doing number 1, you could begin to wiggle the number 1 cylinder back and forth, break its seal to the case, which it's got an O-ring down there, and so sometimes it seals itself to the case a little bit. You may have to hit it a little bit and break it free, and then begin to wiggle it up out of there. This is a good point to have a friend handy to help you, because that, as soon as you get that cylinder off the piston, the rod is going to try and go clank and hit one side or the other. And so it's a good idea if you just have someone, as you're pulling that cylinder off, grab the piston and rod so that they don't fall over and damage either the case or the rod. Now, once you've got the cylinder off, you can go put it on the table, and you want to deal with the piston and the rod. If you're going to remove the piston out of the rod, or the piston from the rod, you'll want to push the piston pin out of the piston and the rod. And sometimes that goes very easily. Sometimes it doesn't. Sometimes they're stuck in there. The clearances are still good, but carbon and varnish builds up. And if you look at this this close-up of a piston and rod, you'll see that there is an exposed area on either side of the link rod where you can see the piston pin in there. And carbon and varnish builds up on there, and so it has a larger diameter than it used to. So when you try to push that pin out of there, it doesn't want to come out. Now, what is a really bad idea is to hit the piston pin on the end. It's got aluminum plugs in the end, and those plugs damage very easily. So you don't want to hit that thing. What you can do is begin to heat the piston along the axis of the pin. You can see where the pin goes through there. Heat it with a propane torch, and spend a minute or two just heating that piston up. You won't hurt it with a propane torch, and get it nice and warm. And I haven't seen that fail yet to warm the piston up and expand it enough that the pin won't come out of there. So push the pin out, pull the piston off the rod, and then at that point you can support the rod in the center of the hole. Not because if it's any rod other than 7 it really matters. You just don't want it to hit anything. One way to do that is by using a couple of heavy rubber bands and just go around the rod from both directions and rubber band it to the studs so it's held there in the center. Pratt & Whitney actually made a special device to hold the rod in the center, and you can see what that thing looks like, but it's a little bit large for the Lycoming engine, so works on Continentals and Jacobs, but not so much for the Lycoming because it has a smaller bore. So let's go over to the table, and we'll look at some pistons, and we'll look at that cylinder a little bit. We were talking about those link rods that we wanted to keep from hitting the engine case, and I'd like to mention something here. These are both Lycoming link rods. This is an aluminum link rod made by Alcoa, and all of the lower horsepower R680s use this aluminum link rod originally. The 215s and then the early 225s, And it wasn't until during World War II that they upgraded the 225 and it began to use the steel link rod, which is the link rod that's also used in the 300. So this rod is now interchangeable in both the later 225s and the 300s. Now, you don't want to take an early 225 and put a steel link rod in it. It's the crankshaft is completely different. They're balanced completely different. And so we did see an engine that came into us once that was designed for the aluminum link rods, and it had steel link rods in it. Shook like a wet dog, and so it was trying to throw itself off the engine mount. So you can't interchange these, but these were designed for that early 225, and then these were for the dash 17 R680 dash 17 225 horse, and then all of the 300 horse engines. I have here 4 pistons. You'll notice that these 3 pistons are all the same height, and they all have flat tops. These are all low horsepower pistons, and this is a domed piston for a 300 horse. I'd like to look at some details on these things, because I think that it would be important, if you're going to have a cylinder off, that you be careful that what you put back in there is the appropriate piston for the engine. Though these pistons look very similar, they are not. And you could get into big trouble balance-wise by interchanging these. So I'd like to take a little bit more of an in-depth look at these pistons and talk about the differences. The piston on the far left, if we look at the side view, the crown of the head is flat. The close-up shows that the part number is a 420 KB. This is the piston that is used in all of the 225 horse engines. Bottom view shows a smooth head on the inside, and a close-up of that bottom view shows some numbers. It shows that the compression ratio is 5.5 to 1, and the weight is 1.97 pounds. That's your standard 225 horse piston. The next piston to the right looks very similar. The side view shows that the crown of the head is flat, but the part number is a 420M piston. If you look at the underside, there are fins in the head, and the close-up of the numbers stamped there shows that the compression ratio is 5.5 to 1, just like the 420 KB. But it shows that it has a weight of 2.18 pounds. Now you remember that the 420 KB was 1.97 pounds. This is 2.18 pounds. That's 0.21 pounds, or 95 grams of difference. When we build our engines, we build the engine so that the rotating mass is all of the individual pistons are within 3 grams of one another, and so this is 95 grams heavier than that other piston. The next piston over is again flat on the top. There's no part number on the side like there was on the other 2 pistons. The underside shows it to be smooth like the 420 KB 225 horse piston. But the close-up on the numbers shows that this is a 5.3 to 1 compression ratio piston. So it's a lower compression ratio piston. This was actually the piston that was used in that 215 horse engine. And the weight on this one is 1.95 pounds. Now the weight on the 225 horse was 1.97 pounds, so there were only 0.02 of a pound difference between those two. Those 2 pistons would probably run in the same engine, except the compression ratio is wrong. So you've got a compression ratio of 5.3 to 1 in the early one and a 5.5 to 1 in the later one. Now moving one more piston over, we have the 300 horse piston, which you can see is a domed piston, and on the side of it is stamped 420 PXA. Now this is actually a 420P piston. The XA means that it's an oversized piston. X means oversize, A means the first oversize, which would be plus 10. If it was a plus 20, it would be a 420 PXB. And this holds true for the other pistons as well. On the 420 KB that you use in the 225, it would be a KB XA or XB if it was oversized. Now you'll notice on the underside that this one has fins like the 420M had, but they're different spacing and they're different number of fins. And the compression ratio on this one is a 7.1 or 7.0 to 1. And the weight is 2.23 pounds. I went through that little drill just to say this: be careful what you put back in your engine. If you do a top overhaul on a cylinder, and once you get the cylinder off, you look at the piston and it has some scoring in the side of it that you don't like the looks of, and your buddy says, well, hey, I've got a brand new piston in a box, you can put that in. Be really careful that the compression ratio is right, that the configuration on the inside of the head, whether it has fins or not, whether that's right. Be careful of the weight. You play around with the weight very much, and you can wind up with an engine that vibrates badly. So just be careful. There are a lot of Lycoming parts floating around out there, and just because it will fit in that hole doesn't mean that it's the correct part for it. All the Lycoming engines have the same bore size. They don't all have the same compression ratio, and the pistons certainly didn't weigh the same. So just be careful with that. I would like to talk a little bit. I've got a cylinder here on the table and a piston, and what I'd like to do is just go through compressing the rings and putting this thing in, demonstrate to you how we do that. We use this little KD tool. Is called a wrinkle band, and you can buy them at automotive stores, and it's a great ring compressor, best ring compressor that I've ever used. And it comes apart so that once you've installed the cylinder, you can pop this thing apart and get it off of there. And it's just a neat little tool. It's not expensive. It works fine, lasts a long time. So we've got a piston. I've already fit the rings to it. Be careful when you're reinstalling rings. Be careful that your side clearances are good. That's often a problem where the rings wear out, or the rings and the pistons wear out in that top ring groove. You don't find the other grooves worn so much, but the top ring groove wears badly after a few hundred hours. So be sure that the side clearance is right. That's in your table of limits in the overhaul manual. The rings, the top 3 rings or compression rings, are all the same part number. The oil control ring is the 4th ring down, and then the oil scraper ring is the 5th. The top 4 rings are all bilaterally symmetric, so there's no up and down with them. They'll go either way. The bottom ring definitely has a top and a bottom, and if you look at the overhaul manual, it shows how that's to be oriented. It looks wrong. Every other radial engine out there uses that ring the other way around, but this is how Lycoming chose to do it, so this is what we're going with. A question that we sometimes get is about ring gap spacing. We've got 3 compression rings that are all the same. So what we do is we gap those at 120 degrees apart. Now you won't find this in the manual. They assumed we knew this. So we gap these things at 120 degrees apart. Then we gap the 4th ring, the oil control ring, at 180 degrees to that 3rd compression ring. And then we gap the oil scraper ring at 180 degrees to the oil control ring. So that's how we set these up, and that way the gaps are staggered. It's very unlikely that that they'll line up, and we'll have a problem that way. This is our piston pin. Before we install the piston pin in the piston, we want to lubricate everything, so we put assembly oil, which can be just Aeroshell 100, works great. Cover all these parts with that oil, but you'll find that the plugs, the little aluminum plugs that go in the end of the pins, they fit loosely in there, so they will fall out very readily, and it's kind of a hassle to be trying to assemble this thing, and the plugs are constantly falling out. So if you take a little bit of grease and put a little grease on this plug, or at least on the bottom side plug, it'll glue it in place, and it won't have a tendency to fall out during the assembly, and the grease will melt out of there, and you won't have to worry about the grease doing anything bad. So the first thing that we'll do is we will, and you know, you'll be doing this on the airplane, not on the bench, and so it's a little more interesting. In some ways it's easier, in some ways it's harder. But we'll take some assembly oil, and we'll oil everything up here. Get some down in the piston pin holes. Oil up our pin. We don't have to worry about the top side plug, it won't fall out. And then we'll use our compressor. We'll compress the rings. The cylinder. We're working the rings in. Now once we get to this point, we release the compressor, put the pin, the rod will be here, and then we put the pin through. We push the piston further in. Now the pin is trapped, so the plug can't fall out of it. Then we recompress that ring, that oil scraper ring, and then we continue on with installing in there. It's actually much more difficult to do this on the bench than it is to do it on the engine, because on the engine you've got a rod that's attached to a master rod that's attached to the crankshaft, and it all kind of stays put. Here you're fighting all this on the bench. But anyway, so you put a new cylinder base O-ring around the cylinder base, lubricate all of that thoroughly so that when it goes into the case it will slide easily. And then install that into the case. Now once that's done, you can put the cylinder base nuts back on again. Cylinder base nuts are reusable. There's no real reason to reject them unless there's a problem that you see with them. You torque them down. When you torque them, the overhaul manual again gives you the torque for those, which is 300 inch-pounds, and torque them in an X pattern. So this side, that side, this side, that side, back and forth, back and forth. And what I usually do is I do it 3 times. I do a complete torque of one cylinder 3 times, then I go around it the 4th time in a circle just to verify that I didn't miss anything. And it's probably paranoid, but I feel better about it when I'm done. Then you install the PAL nuts over the top of the cylinder base nuts. Always use new PAL nuts. Used PAL nuts are not trustworthy, and so always use new PAL nuts. Then go back and adjust your valves. Wow, I'm getting a little bit ahead of myself. Put the push rods, push rod tubes, push rods, intake pipes, your baffles if you've got baffles back in, put the exhaust back on, and then you can put the push rods back in, put the adjusters in, adjust the valves. We've already set the engine at top dead center on the compression stroke, so both of the push rods are on between the lobe of the cam, and so they're ready to be adjusted, and adjust those. And then the gaskets that you put back on, there are the original cork, paper, asbestos gaskets are still available. They really weren't a very good gasket, and the rocker covers on the Lycoming engine are very flexible. You can literally take a Lycoming rocker cover in your hands, twist it by hand, and put a permanent bend in it. If you have a surface plate, you check it, it's flat, you get out there and you twist it, and then check it again, it's bent. And so it's a very flexible cover, very fragile, and as a result, just the pressure of putting torque on the nuts is enough to deform the cover, and then you have leaks. So one of the best things that's happened in years has been the Real Gasket Company, about 15 years ago, came out with a silicone gasket that will just really help with stopping leaks. They don't need nearly as much torque as the originals did, and they do a good job of sealing up the engine. So when you tighten those, tighten the silicone gaskets just enough that they barely begin to bulge, just begin to bulge, and then stop. If you use the torque values that are in the book, those were for the paper asbestos gaskets, it'll cut the silicone gaskets right in two. So just make them bulge a little bit, and they'll be fine. And that should be everything for your cylinder replacement.